Hello, greetings, and welcome to A Ramble with me. Today we are looking at question 9 of the department's November 2023 paper 2. Let's get into it without further ado. So in the diagram, ABCD is a parallelogram. Okay, so from the jump we know the opposite sides are parallel, the opposite sides are equal. Cool, yeah, so those are key things that we know. And we're told that AB is equal to 14 units, so that means DC is also 14 units long. Okay, let's fill that in so long. Right, it's not a great S. Right, okay, well, okay, so AD is produced or extended to E such that AD to DE is 4 to 3. So if this is 4 units long, this is 3 units long. If it's 8 units long, this is 6 units long, and so on. EB intersects, okay, so I don't know how I'm going to flag that for myself. Okay, I know how I'll flag it for myself. I'll say that this is 4K and ED will be 3K. Okay, just to remember the ratio between those two sides has been given to us. Okay, where K is some integer, of course. All right, not integer specifically, natural number. All right, kind of negative lengths. Right, so maybe let's scribble that somewhere. So where K is some natural number, 1, 2, 3, 4, etc. EB intersects DC in F. Okay, cool. EB is 21 units long. Okay, so let's fill that in as well. Okay, it's not a great one. Let's try again. Slightly better. So we're told that that is 21 units long. Okay, right. Calculate with reasons the length of FB. Okay, so what stands out to me about the position of FB is, we have this triangle, two sides parallel, and so therefore these two sides are split by the parallel line in the same proportion. So EF to FB will also be the same ratio as ED to DA. So let us indicate that to ourselves. So let's use iPad is busy absconding here mid-video. So we know that the ratio of EF to FB is the same as the ratio of ED to DA. Okay, and I'm just writing the letters in all the wrong. You know what, let's just write it the same order it's been given to us. So they gave us the ratio of AD to DE, even though you can just switch it around. Switch it around. But anyway, just so that it's very clear. Okay, so this ratio is then the same as the ratio of this side to this side. So it's the same as the ratio of FB to FE. Right. Which is indeed the ratio 4 to 3. Okay. Oh, and we need a reason. The reason is, I always forget how to give this reason. I think it's something like line parallel to, so let's actually just name the line as well. So line DF is parallel to the third side of triangle EAB. Ooh, yeah, this squeezing job is not working. let's try to write it again over here, and then we'll just shrink it. Line DF is parallel to third side of triangle EAB. Okay, right, so let us shrink that. Okay. If that's not how to give the reason, Ish, forgive me. I don't know how many times I've looked this up. It's refusing to stick. Anyway, so now we know that EB is equal to FB plus FE, right? And so therefore 21 is equal to 4m plus 3m, right, where m is some natural number. Okay, so we don't know how long each of these is, but we know that the ratio is 4 to 3. So if this is 4, this is 3. If this is 8, this is 6. The same rationale from here. Okay, so we can then figure out, oops, jumping the gun, what m is by solving this equation. So m is equal to 3. So what is that telling us? That is telling us that FB is equal to 4 times 3, which is equal to 12 units. And as a bonus, EF will be 3 times 3, which is 9. So the ratio is 4 to 3, and the length of the side specifically is 12 and 9, which adds up to 21, and also have the ratio 4 to 3. Okay, cool. I think I'm gonna do this one by faith and then check all the answers at the end. Okay, so second question says, prove with reasons that triangle EDF is similar to triangle EAB. Okay, so this is your classic one triangle embedded in the other, and there's one side parallel to the other, so you're going to have your corresponding angles, and then you have a common angle. You know, it's very, very textbook similarity proof. So in triangle EDF and triangle EAB, the angle E is common. Okay, and then angle A, okay, let me keep the same order as the triangles. So angle EDF, so this guy, is equal to angle EAB because corresponding angles on parallel lines, and we can name the parallel lines, so that's DF parallel to AB. Okay, and then the last one, EFD, okay, which is this guy, is equal to EBA, which is this guy, and same reason, corresponding angles, DF is parallel to AB. And so this proves that triangle EDF is similar to triangle EAB, and the reason is they have the same set of angles. Okay, and then the last question says, calculate with reasons the length of FC. Okay, so we know the length of AB. We were told that that is 14 units, and we know the ratio between these sides, which means, so we know that the ratio between ED and DA is 3 to 4. So the ratio between ED and the whole of this side is 3 to 7, which is the same ratio as DF to AB. So if we know that this is 7 parts, then we can work out what 3 parts is. Okay, so we know that the ratio ED to AD is equal to 3 to 4. It's just switching this ratio around, right? And that we've been given. And so therefore the ratio between ED and the whole of EA will be 3 to 7, right? And we know that, I'll just repeat what we proved here. Okay, so I'll just shrink it. Oops, left an E behind somewhere. So we know that DF and AB will then also have the same proportion as ED to EA, ED to EA. So it's also going to have a ratio of 3 to 7. So DF to AB is also going to be equal to 3 to 7, and this is actually the reason. Oops. Guess we can make you slightly bigger. Okay, right. And so because we know that AB is 14 units long, so that means we have DF to 14 is equal to 3 to 7, right? And to go from 7 to 14, we're timesing by 2, right? So to go from 3 to DF, we're also going to need to times by 2 in order for these ratios to be equal. So DF is equal to 3 times 2, which is 6 units. Okay, so horrifying looking question, but actually not so bad at the end of it. And I think this is the second last question of the paper, so that's really like not horrible. Right, so just looking at the answers to make sure that I didn't mess anything up, and it is looking promising. Whoa, what we meant? Oh, oops, sorry. Oopsie daisy. Okay, so we're not meant to just work out the length of this, or we will work out the length of FC. Oh my gosh, oops, my bad. Okay, so we've done part of the situation. We've worked out how long this is. So to work out how long that is, we use the fact that, you know, these are the same in length. So this will also be 14 units long. And so, so let's just say, so DC is equal to AB is equal to 14, because opposite sides of a parallelogram are equal, right? So therefore FC will be equal to DC minus DF, which is 14 minus DF we found to be 6, which is 8 units. Okay, yes, now now it is complete. They also have an approach where they use the similarity of these triangles. They would be similar because these two angles are equal. These angles are equal, alternate angles, and therefore these two are equal. And then we know, what did we work out in the other question? We worked out the length of something. Well, we would be able to work out the length of DF the same way that we just worked it out. We worked out the length of FB previously on WWE SmackDown, and we would know the length of this, so then we would know, okay, what is the, I mean, I presume these are the proportional sides in these two triangles. Let's see, these two angles are equal, these two angles are equal, yes, so this and this would be the proportional sides, and because we know the length of this and the length of this, then we know, okay, the proportion of all the sides to each other. So if we know that and we know this, then we can work out this, because these two are the partners from the two triangles. Okay, this is really a ramble.com, but yeah, hoping it makes sense. In and amid. Okay, cool. Let's leave it at that, and I hope you'll join me again for the finale of this paper. Yeah, catch you there.